Okay, we're looking at a parabola here. Now, you have two forms of parabola, let's say vertex form. You have the one where it says y is equal to x minus h squared plus k, and your vertex being h and k, your h being x and your k being y. You're also presented with parabolas that face in a left and right direction, and that's when, so these parabolas will actually face this direction, a horizontal curve, let's just say, and you have the y minus k squared plus h. Notice the difference here, 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 and here. These are switched here, and you also have a switch of the y and k. So let's just look at this first equation that gives x is equal to 5, y plus 8 squared minus 1. This is an easy setup, right? This is basically my y minus, now this is my k. I like using this because it reminds me this is my k, and this is my h here. Now, notice that in the parentheses it says y plus 8. So how did you end up with a plus in the parentheses if it says y minus k? Well, this was y minus a minus 8 squared. And so we need to identify that our k or our y was actually a negative 8. So a lot of times when you see this positive inside the parentheses, right away it's signaling to you that it's not a positive 8, it's a negative 8. You don't have to go through all this, but it's helpful to understand. And then my k, which again was, I believe this is minus k. Let me pause. Okay, we're okay here, plus h. So again, how do we end up with, since it's plus h, the fact that it's negative 1, it's okay. There's no real sign change here. You're just simply, it's plus h. It's plus your negative 1, so h is negative 1 here, right? Or would we say this is positive? No, you couldn't say it's positive, because if you're putting in a plus positive 1, that would be a plus 1. You see? So there's no sign change here when you're dealing with that. The sign change happens here because you're starting with a negative. So we have a vertex of plus 1 and negative 8. So we go, now we go where x is 1 and y is negative 8. We plot our vertex. Now this letter here in your vertex form is a. Okay, a equals 5. Now there is a certain thing to remember when a is greater than 1 or a is less than 1. One will make the parabola face left and one will make it face right. Let's see by plugging in which rule, because maybe we don't know the rule, which rule that actually gives us. So what I like to do is, since my vertex doesn't have a 0 in it, I'm going to plug in 0 for y. Actually, I'll cheat this one, and as a cheat, I'll make y. No, I can't make y negative 8. That'll make it 0. Okay, I'll make y 0. So 0 plus 8 squared minus 1. That gives me 5 times 64 minus 1. Now, notice that we're seeing by plugging a 0, we're going to get a pretty big number, and that's not something we want to do. So how can we make this like a 1? Well, let's use y equal to negative 7. And I like using that because if our y was negative 8 and we just want to see where that parabola is moving, we'll just move 1 unit to negative 7. So I'll do 5 times negative 7 plus 8 squared minus 1. That gives me 5 times 1 squared minus 1. That gives me 5 minus 1. That gives me 4. So when y is negative 7, my x is 4. So I'll go where x is 4, and I'll plot the -7 here. And when you're working with your IXL, you only really need these 2 points. Ooh, I made a mistake there. You only need these 2 points to make your parabola. And what you see here is that when a is greater than 1, like here was here with 5, our parabola is going to face to the right. If it's less than 1, our parabola is going to face in a negative direction. Basically, our x's will be going down, where in this case, our a was positive 5, so our x's were actually going up. And this is where you have it already in vertex form. Another example here. This one, same thing, but I wanted to point this out because you have a fraction here, and it switches to y. So you have y is equal to x minus h plus k, and don't forget the squared here. Notice when it's x, this would have been here, this would have been k, this would have been h, so it's inverted. And then we have y is equal to 4 x. Now, if it's x plus 1, that means it was x minus a minus 1 squared plus, and I'm going to switch this to a 4.5. I like doing that. 2 goes into 9 4 times with a half left over. So my x is -1 and my y is 4.5. So I can go ahead and go where x is -1, where y is 4.5, and I have a -1, 4.5. And that's my vertex. Now, kind of same thing. If my x is greater than 1, my parabola is going to face a positive direction. If my a is less than 1, less than 1, my parabola is going to face in a negative direction. Now, how do I want to plug in for this and end up with a good number to work with? So if I was at -1, I think a good number to use it, like, so basically my x coordinate in my vertex was -1. So maybe I just want to go 1 unit either direction. Probably want to use 0. That'll make things easier for me. And then I end up with 4 times 1 squared, which is 1. 4 times 1 plus 9.5, or 4.5. 4 plus 4.5. So when x is 0, my y is 8.5. So I go here. We'll use a different color. 0, 8.5. We know it's facing up. And here I have a parabola that's facing upwards. And that's how I'm able to graph my vertex. You only need 2 points and an additional point here. And that's when you're given the parabola in a vertex form. Now the problems start to get a little bit more challenging, and you end up with something like this. And this is no longer in vertex form. This is actually in standard form. And this is a little bit of a review from last year, where you had ax squared plus bx plus c. You had this standard form, vertex form here, standard form, but notice that it has x equals. So it's just if it's x equals, it just turns into a y squared plus by plus c. And then your y is equal to -b over 2a. If it were y equals, your x would be equal to -b over 2a. So this is a way where I could solve for my y. Now I'm going to use my -20. This is my b here. Minus a -20. Common mistake is to not put in the -20 here and just call it a -20 over 2 times -5. I get 20 over -10. I get -2. So my y in this case for my vertex is going to be -2. Now if I want my x, all I need to do is just simply plug in -5, -2 squared, minus 20 times negative 2. I'm just plugging in my y, and I could get my x. I think this is negative 4, negative 20, plus 40, minus 11, 40 minus 11. I'm sorry. 20 minus 11 is 9. So that's how I found my x value here. So my x is 9. So I can go ahead and plot that as my vertex. 9, negative 2. And I know that because this is a negative number, my a is negative, this graph is potentially going to be facing this direction. And if the y in my vertex was negative 2, I'm going to use a negative 1 here. I'm going to go 1 off to get my additional point. And all I'll do is I'm plugging in negative 5 times a negative 1 squared minus 20 times a negative 1 minus 11. I get negative 5 times 1 plus 20 minus 11. Negative 5 plus 20 minus 11. Sheesh. Negative, that's 15 minus 11. 4. Oh, my math is on point today. So if I plug in a negative 1 for my y, I'm going to get a 4 for my x. So I'll plot that point right here. Now, if it's so think about it like this too. If it's like my vertex is here and I've gone 1 unit, then my other point on the other side of parabola will be here. It'll be at negative 3. It's kind of has that same. Let me explain that a better way. So basically, we only need to find this 1 point here to complete our parabola. But notice that from our axis of symmetry here, it went up 1 when we went up 1 in y. If we go down 1 in y, it's also going to go down 1. So a parabola is symmetrical. So that's something you also want to look at. You know, if I plug in a negative 3 for y, it would have also given me a 4. So you could use either value. And then we have one more to look here. And this one could get kind of wild here, but we're looking at, okay, first of all, I see right away, and this is like a level 7, I see right away I have multiples of 4. So I'm going to take this whole, of 2, I'm sorry. I'm going to take this whole thing and divide it by 2 and get a y squared plus 12 plus 2x minus 8y. So I've simplified this whole thing, and I recognize that it's the y that's squared. So actually what I want to do is I want to kind of rearrange this to have x by itself. And this is where it's going to get a little complicated, but that's all right. I'm going to bring this y this way, and I'm going to bring this 12 this way. So I'll have 2x is equal to, let's say, negative y squared. I'm subtracting y from both sides, minus 8y plus 12. And then I have to have x by itself if I'm going to have a standard form here. So I'm actually going to get x is equal to negative 0.5 y squared minus 4y plus 12. Nope, plus 6. And then my y is going to equal to negative b over 2a, which would be negative 4 over 2 times negative 0.5, which is a 4 over 4, or negative 4, or a negative 1. 2 times a half is 4 halves. right? Check that. I think I'm having a brain fart. No, it's 1. I'm sorry. I knew I was having a brain fart there. Here you go. 4 over 1, negative 1. So my y in this case is or my, yes, is negative 1. Go ahead. Yeah, that's a good catch too. So we should have a negative 6 there. So my y is negative 1, and then I could just plug that in. Let me just use a TI-83 to make this move a little faster here. So negative 0.5 times, plug in the negative 1 squared minus 4 times the negative 1 minus the 6. That's a negative 2.5. So my x is negative 2.5. So if my y is negative 1, my x is going to be a negative 2.5. And here would be my vertex. And because this y here, this number here is a negative, this a is a negative, it's less than 1, my parabola is going to be facing to the left. And if I want to just go 1 unit from negative 1, I could use a 0. I'm actually excited about that because that saves me a lot of math. Negative 5 times a 0 squared minus 4 times a 0 minus the 6. These are just 0, so I'm left with negative 6. So when y is 0, my x is a negative 6. So I can plot that point there. And I can work this way. Now the other thing you could do is you could, if this is the dividing by 2, the moving everything getting x by itself, if this is getting to be a problem that is complicated for you, then you can rearrange this to get y by itself, or you could somehow put this into Desmos, but you have to get it where it's by itself. And the other problem is this is x equal. So this would be a pretty tough problem to come up with a parabola even on Desmos. You have to get x by itself. You could put this, let me give you like a little quick Desmos cheat. So let's say, for instance, plugging in a negative 1 for y, and then a negative 2, a negative 3, you would have come across your vertex. You would have built that graph. You can do this by just plugging in values for y. And, maybe what you would do is, to help yourself is, get x by itself and then plug in. But even so, you could just plug in for y and solve for x on each. So, yeah. Any other questions? Let's say you had that x is equal to negative 0.5 y squared. I forget what it was. Let's just say 4y minus 6. You could go to Desmos and put this in as a negative 0.5 x squared plus 4x minus 6, and then just look at the graph rotated, because what this would have done is it would have gave you a parabola that looked like this, and then you could just rotate it by looking at it and try to come up with some of your values. And you could also go to the settings on the Desmos and ask for a table. And that would be helpful as well, because this is a pretty advanced problem. But just go back through this, and then always the end result of any of this, if you can't find a way to come up with a vertex form, then using or plugging in values